So now moving to the last section of this chapter on remainders, we'll see how we can use some of the concepts of algebra, basically some of the identities that we have learned in algebra to find the remainders of some expressions. We will see how we can use these identities and say if a particular expression is divisible by a number or not, or we can say if it is not divisible by a number. Let's start off with one of the most common identities that we know, which is a squared minus b squared. We know a squared minus b squared is equal to a plus b into a minus b. Or we can say a plus b and a minus b are factors of a squared minus b squared. Now, a power 4 minus b power 4 is equal to a squared plus b squared into a squared minus b squared. And we can further factorize this a squared minus b squared into a plus b into a minus b. So we can say that for every even n, that is when n is even, a power n minus b power n will always have a factor of a minus b and a plus b. That is a raised to n minus b raised to n when n is even will always be divisible by a minus b and a plus b. A minus b and a plus b being factors of this means that this is always divisible by a minus b and a plus b if n is even. So now let's make use of this concept and see if we can find the remainder of this expression, that is 22 to the power 44 minus 18 to the power 44 divided by 40. As we just now saw, a power n minus b power n will always be divisible by a plus b and a minus b if n is even. That is what we just now saw. So in this case here, a power 22 to the power 44 minus 18 to the power 44, n is even. So that means this 22 to the power 44 minus 18 to the power 44 will always be divisible by a plus b, which is 22 plus 18 and 22 minus 18. So how much is 22 plus 18? It is 40. So that means this expression will have zero remainder, or it will not have any remainder.